Hello friends, today we're going over modeling with quadratics. If you didn't watch the first video where we learned how to program a quadratic formula into our calculators, you should go back and watch that one first. Alright, so you should pause video and try the warm-up on your own. Since you're probably not going to do that, I'm just going to continue on with it. So y-intercept we know happens whenever x equals 0. So if I let x equal 0 up here, I'm going to get a value of 10. So the y-intercept is just going to be 0, 10. So we like standard form for that reason. Really easy to give us the y-intercept. For the maximum value, so what we need to remember about this is if we were to graph this little negative 2x squared. So negative means it's going to be upside down, and an x squared graph means it makes this U shape. And so that means that it's going to have a maximum value at some point if it's an upside down U. And we know that that's going to happen at the vertex. So what we can do is find the vertex, and that's going to give us the x value of the maximum, and then we could plug that in to find what the y value of the maximum would be. And we know that to find the x value of the vertex, we just need to do negative b over 2a. So that's going to be negative 8 over a negative 4, which is going to give us a positive 2. So the x value of the maximum is going to be at x equals 2. For us to find that maximum value, we're going to just do y of 2. So that's going to be negative 2, 2 squared. So I'm just plugging this back into the original equation way up here. Right, so then plus 8 times 2, so that's 16 plus 10, and I think that equals 18. So our maximum value is going to be at 18. Next, it asks us what are the x-intercepts. So we can either factor or do the quadratic formula. Factoring is always easiest, so that is what I will do here. I'm going to first factor out a negative 2. That'll give me an x squared minus 4x minus 5. And let's see, so that's going to be x minus 5, x plus 1. And I set each one of these things equal to 0. This one gives me nothing. This one will give me 5, 0 for an x-intercept, and this guy here will give me negative 1, 0. So those are our x-intercepts. All right, so let's get into modeling, and we're going to be using this maximum property and the x-intercept part as well a ton in today's lesson. So first thing we got is projectile motion. So projectile motion is basically when you throw a ball in the air, it kind of travels in a parabola-like shape. You know, you throw it up and it comes back down. And it's actually modeled by this equation right here, negative 16t squared plus v, which stands for the initial velocity. So how fast you are releasing the object that you're throwing or projecting into the air. And then we have plus h little 0 here, and that's called the initial height. So that's v0, which we pronounce as v naught, kind of like how some British people don't say 0, they say naught instead of 0. So it comes from that. So v naught and h naught, and it just means that the initial velocity and initial height at time t equals 0, basically. You're not going to have to memorize this formula. We would either give you this formula with its pieces, or we would actually just write it out for you. So I wanted us to practice writing this out. So we have an object is launched vertically upward from the top of a 100-foot tower at an initial velocity of 80 feet per second. So our equation is going to be h of t. We're modeling the height as a function of time, equals negative 16t squared. This negative 16 comes from gravity, actually. So the acceleration due to gravity is negative 32 feet per second squared. And there's a whole bunch of calculus and physics involved that somehow ends up making this be negative 32, turn into a negative 16t squared. And we're always going to be feet and seconds. Next, we have plus the velocity. So our velocity was 80. And t, don't lose your t there, plus the initial height was 100. So you might notice I'm making my t's have like a little tail on the end. That's so that they don't look like the plus signs. It's really easy to lose track of your t's and your pluses when we're doing this. So just be careful. Part B says, when does the object reach its maximum height, and what is the maximum height of the object? So this is basically it just asking us to find the vertex, because we have a negative t squared, a negative x squared graph. This is going to have a maximum value. So the when is going to be at negative b over 2a. So that's going to be negative 80 over 2 times negative 16, so a negative 32. And we would use our calculator for this to get 2.5, and then we include our units here, seconds. Okay, so when will it reach its maximum height? At 2.5 seconds. Now, what is that maximum height? We're going to do h of 2.5. And then again, you'll just use your calculator to type this in. So we would do negative 16, parentheses 2.5 squared, plus 80 times 2.5 plus 100. I'm just being a little lazy and not switching over to type in my calculator. But you should get 200 feet there. Don't forget your units. Now, when does the object hit the ground? So the object's going to hit the ground when our height is 0. So if we set this equation equal to 0, then we could either factor it or we could use the quadratic formula. We're going to choose to use the quadratic formula, and here's the work that I want you to show me. I want you to tell me what a, b, and c are. Okay, so a, negative 16, b, 80, and c is 100. And then I want you to write out what the quadratic formula is. So you're just going to write negative b plus or minus the square root of b squared minus 4ac. So you're not plugging anything in. You're just doing this. And then we're going to jump and use our calculator with our program that we just made. Okay, so we're going to start off by hitting program. So remember, that's 3 over and 3 down. We're going to pick our quadratic formula. I'm going to hit enter again. And this time I'm going to say, all right, a is negative 16. B was 80, and C was 100. And here are the two values when this thing has an H value of 0. So negative 1.035 and 6 point whatever that was. So negative 1.035 and 6.035. Now, we have to remember that this is talking about t. So negative time doesn't exist yet. So that means that we're only going to pick the positive one. And again, it's time, so it's in seconds, because for these projectile motions, we're always going to be in feet and seconds. There are other equations that use meters per second. We're going to stick with the height one for now. This is the work that I need you to show me. So in part B, I need you to show me that you're doing negative b over 2a, but then you can use your calculator to do the rest of it. You know, for the maximum height, I need you to show me that you're doing h of 2.5, but I don't need to see the in-between work. For part C, I need you to tell me, oh, I'm letting h equal 0, and I'm doing the quadratic formula with these a, b, and c values, and this is the answer I get, but I don't need to see the in-between stuff. Okay, so we're starting to use our calculators to help us so we don't have to do as much manual work and don't have to write as much. Okay, so we're going to start relying on our calculators a little bit more. All right, it's your turn, so you should pause the video and try this on your own. Did I wait long enough for you to pause it? You probably didn't pause it, did you? Such a troublemaker. All right, Little League team uses a throwing machine to help 10-year-olds play catch. Oh, God, I cannot read. To help them practice catching pop-up balls. Okay, so ball is thrown straight up in the air with a initial velocity of 48 feet per second, height of 3.5. So we're going to use that equation. So h of t equals negative 16t squared plus the initial velocity, so 48t, plus the initial height, 3.5. We want to know what the height of this ball is at 3 seconds. We want to do h of 3. So let me show you in the calculator now how I actually do this. So what I actually would do is hit 3, hit the store button, which remember is right above on, and store this as x. And then I would just type our equation in. So negative 16x squared plus 48x, and then plus 3.5. And since the calculator thinks x is currently 3, it's going to calculate that out for me. So I get 3.5, and that is actually the answer to this one, 3.5 feet. Okay, so we're starting to use the calculator to help us do this math. At what time does it reach its maximum height? So we're going to do t equals negative b over 2a. So that's going to be negative 48 over a negative 32, which I think is 1.5 seconds, but you'll have a calculator for this question, so you would be able to confirm that. And then what is that maximum height? All right, so we're going to do h of 1.5 this time. So if I flip back over here, what I can do is now say, hey, I want to store x as 1.5 now. In a fancy calculator, you can just hit your cursor up and go grab it. In a not as fancy one, if you just hit second enter and second enter, it will keep bringing up the previous thing. So we want to just re-get the negative 16 x squared so we don't have to keep rewriting it over and over. And I get this 3.95 feet. I lost my mouse there. Okay. Struggling a little bit right now. All right, so that's our max height. So max height of 39.5 feet at 1.5 seconds. When will the ball hit the ground? So we're going to say, hey, the ball hits the ground at a height of 0. And our A value is negative 16, our B value is 48, and our C value is 3.5, and we're going to use our quadratic formula. So again, you don't need to actually type any of these values in, you just need to write to say, hey, this is the formula I'm using in order to calculate this. So I'm going to do program, my quadratic formula, hit enter, enter the A value, so negative 16, B was 48, and C was 3.5, and we get these two numbers here, okay? So negative 0.07 and 3.07. Negative time doesn't exist, so 3.07 seconds it is. Ta-da! Math. Hopefully you said yay or something like that. All right, so we're gonna start off on doing one of these examples called an open top box. We're going to do one where we would not have our calculator, which means that we can definitely solve it without the use of a calculator. And then we're going to do one where we 100% need to use our calculator. And when we get to number 5, it's not actually going to make a quadratic, it's going to make a cubic, and we're going to deal with that in a little bit. All right, so we are constructing an open top box from a flat piece of paper. So basically what we're going to do is take a flat piece of paper and we're going to cut the corners off of it, and then we'll be able to fold it up. So if you can't visualize what that looks like, I'll show you an example the next time we're in class. But also you could just go grab some scrap paper off the side and just like cut the corners off. So you're going to like remove this part here, 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 and here. And then when you fold it up, you should be able to see that it'll create a box that doesn't have a top. Okay, so it has a bottom and it has sides, but it doesn't have a top, so an open top box. For this particular example, we are going to be cutting corners that are 9 centimeter squares. So from all 4 corners, we're cutting 9 centimeter squares. And we want the box to hold 144 cubic centimeters. We're trying to figure out how big should the original piece of paper be. Okay, so we don't know how big the original thing is going to be. So when we look at this value right here, what is going to be x, and then minus the 9 from each corner, and this part here will also be that x minus the 9 from each of the corners. And so hopefully you understand how these two things are both going to be x minus 18. And then when we fold up the side, this side that gets folded up, these kind of meet together when we fold them, and that creates the height of the box, which you can see over here is the 9 centimeters, okay? So these two pieces right here that I'm scribbling in green, that hopefully you can see, those end up creating the bottom dimensions of the box, and then the corners create the top part. So our volume, which is length times width times height, will be 9 times x minus 18 times x minus 18. And they told us that our volume needs to be 144. So we can start off by actually saying the volume is 144, and then we do our length times our width times our height. Okay, so we end up with this. First thing I'm going to do is actually divide the 9 to the other side. So 144 divided by 9 is going to be some number that I totally know off the top of my head. I think it's 16. And then I actually have the x minus 18 twice. So we can actually write this as something squared. And we're going to be able to solve with the square root method. So I'm going to end up with a plus or minus 4 equals x minus 18. And now I just move the 18 to the other side. So I have 18 plus or minus 4. That's going to give me 18 plus 4 is 22. And it's going to give me 18 minus 4 is 14. Now, let's talk about the domain of this problem before we go too much further. So we have to think about these sides that are right here. So my x value it can't be smaller than 18, because if I'm removing 9 from both sides, then I need to have at least 18 inches there in order for it to not just completely overlap the corner. So this, highlighted yellow X part up here, it has a domain value that says it must be greater than 18. Otherwise, when I do this subtract 18, I'd end up with a side length that's negative, and I wouldn't be able to create this box when we fold everything up. So because of that, we actually can cross off this 14 and say that's not going to work. The 22 is going to work. And we just have to read what the question actually asked us to solve. What should the dimensions of the piece of sheet metal be? So that's our X by X. So that's going to be 22 more centimeters by 22 centimeters. All right, so hopefully you were able to follow along with that and it wasn't too crazy. All right, our next example is going to be a little bit harder variation of this. So, we'll just read the scenario. Amazon has contracted with USPS to design boxes that are going to be used for drones. The squares are going to be cut from 10 inches by 20 inches piece of cardboard, and the flaps are going to fold up to make the open box. So here, hopefully, you kind of get the idea of what's happening with the open top box. Our scenario is a little different this time because we don't know what the corners are that we're cutting off. So these little corners here, we don't know how big they are. But we do know that we started off with 10 inches and 20 inches. So when we go to find this side right here, it's going to be 10 minus the 2 x's from the corners that we removed. And this other one over here is going to be 20 minus 2x. We have a similar idea with our domain. I'm just going to start with that since we're here. Our x value cannot be 0. We have to remove something from the corner to create this three-dimensional shape. So we're going to have that x has to be greater than 0. And now we're going to look at the smaller of the two sides. So 10 minus 2x. X can't be bigger than 5, because if we did 10 minus 2 times 5, that would be 0. And anything past x equals 5, we'll get a negative number there. So basically, our domain is always going to be half of the smaller side, right? So if I did 10 minus 2x, that number has to stay positive. So 10 has to be greater than 2x, which means that x has to stay smaller than 5, okay? So that's the mathematical way, but honestly, you just need to think about it. It's going to be half of the smaller length. That's what you need to make sure that you are smaller than. All right, so when we go to create our volume equation here, we're going to have x, which is the corner. That always is what we start with, the part that folds up. Then we'll have our two bases, which is going to be 10 minus 2x and 20 minus 2x. And they're asking us to maximize the volume of this box. We're trying to maximize the volume. And we don't actually know how to do this when we have an x to the third, which is what we have, because if we distributed this all the way out, we'd have an x times a negative 2x times a negative 2x. So we have to use our calculators because we don't know how to handle finding maximums or minimums of anything other than an x squared graph where we can just find the vertex in that. So what we're going to do is graph this, and I'm just going to preview what it looks like. It's going to look something like this. And what we're going to do is try to find what the maximum is. And that maximum is actually going to be the x value, which is our corner, and then actually the y value is our volumes, because we're putting in a v equals a volume equation. So let me show you that in the calculator. So we're just going to go up to our y equals. You're going to clear anything that you have in there. And we're going to do x, and then we're going to do our parentheses, 10 minus 2x, open up another parentheses, 10 minus 2x. Okay, so don't FOIL this out. Just type this in exactly as it is. Next, we're going to go to window, and we have domain restrictions here. We know that the x values are between 0 and 5. Okay, so I'm going to make my x min and max be between 0 and 5. For my y, I always like to see just a little bit of negative numbers, even though y is standing for volume, and volume can't go negative. And then I normally start off by just doing whatever the side lengths were, which was 10 and 20, and I just multiply them together, and it just does that math for you, and I'll just hit graph. And if you're lucky, you can see the whole thing. If you're not lucky, what you'll need to do is just increase that y max. So let me just give you an example of what that looks like, just in case. So let's say we got a y max of 150. You can see I can't see the maximum, so I would come back in and I would increase it. Okay, so I'm going to go back to I'm going to do 250, just to give me a little bit of buffer up there. All right, and now we're just going to go do maximum, just like we did in the first unit. So we're going to hit second calculate, which is above the trace button, number 4 maximum, and then we just got to move ourselves to the left of the maximum, hit enter, move ourselves to the right of the maximum, hit enter, and then guess. So we get this 2.11 and 192.45. So I'm just going to write that down over here. So that was 2.11 and then 92.45. All right. So that x value, so x was our squares, right? So what size squares should be cut from the cardboard to maximize the volume of this box? So that's the answer to our question. We're going to do 2.11 inch by 2.11 inch. Now, just some other things, just these are sidebars. This was not asked for, but just so we know, the max volume would be 192.45 inches cubed. Okay, so that's one thing. And then another thing would be, what are the dimensions of the box when we fold it? So we would get our x value, so 2.11 inches, and then I would just need to calculate what are these two things here, the 10 minus 2x and the 20 minus 2x. And a neat thing about our calculator is where we found the maximum and got that 2.11, if we go to our home screen, it stores that x value as that 2.11. So we can actually just ask the calculator to do the 10 minus 2x and the 20 minus 2x just for us automatically. So we would get 5.77 and 15.77. So if we were being asked what are the dimensions of the box, that's what we would do. And again, I'm basically just doing, these are the 3 dimensions. This is our length, our width, and our height. So there's my length, my width, and my height. So they only asked for the one thing, which was this, but variations on this question, they could ask you what is the max volume, or they could ask you what are the dimensions of the box itself. All right, you have your turn, so you should pause the video and try this one on your own. You're probably not going to, so I'm just going to jump right into it. An open box is formed from a rectangular piece of cardboard that is twice as long as it is wide. So I'm going to say like 2x by x, and it says squares of length 1 are being removed. So this is the easier of the 2 variations. What we're going to end up with here is this little part is going to be 2x minus 2 because we're removing an inch from both sides, and this little part right here is going to be x minus 2, again because we're removing 2 inches from each side. They want the volume to be 112. What are the dimensions of the actual box itself? So our volume is going to be 112, which is going to equal our length times width times height. So the height of the box is 1. And then we have x minus 2 and 2x minus 2. All right. So what I'm going to do is start off by foiling. So I'm going to get 2x squared minus 6x plus 4. And then we're going to move this 112 to the other side, which is going to give me a negative 108. I'm going to divide all of that by 2, try to get this a little bit easier for me to factor maybe. Okay, so dividing everything by 2 gives us this, and then I think if we do 9 and 6, that multiplies to 54 and adds to our negative 3, so we're going to get x equals 9 or x equals negative 6. That doesn't make sense. Again, we can think about what our domain is going to be. If our x minus 2 is a side length, then our x value must always be greater than 2 so that we don't end up getting a negative number there. So we're just looking at the smaller of the 2 sides and seeing what makes it negative. Okay, so x equals 9. So when I go to do the dimensions of the box itself, we have the 1 inch, which is the corner being folded up. Then I have x minus 2, so that's going to be 7 inches. And then I have 2x minus 2, that's going to be 16 inches. Again, so this is coming from the x minus 2, and this one is coming from the 2x minus 2. And that would be our answer. All right, I hope you're able to follow along with these. They can be a little tricky, but they're very formulaic with the open top box. We're always kind of doing something similar in either variation. This is the easier one where they give you the volume. This example was a harder one because they ask you to maximize the volume and you have to use your calculator. All right, I think we have 2 more left. We have maximizing profits. Okay, so currently the price for an iPod that no one buys is $100, and they sell 1,000 of them per day. Apple found that when they increase the price by $1, they actually sell 2 less iPods. And they want to figure out what is the price that they should sell in order to maximize their profit for each individual day. All right, so our profit is going to be found, and we're using the word profit real loosely here. This is probably not profit necessarily. This is probably just like the revenue that they're bringing in when they sell this, not necessarily how much money they actually make, but hopefully you get the idea. So profit is going to be the number that they sell each day times how much they are selling, right? So if they sell 5 at $100, they made $500. If they sell 4 at $50, then they only made $200 or whatever. So what we have here is they said, hey, we will sell 2 less iPods every time that we increase our price. So what we're going to do is we're going to let X equal an increase in price. And so that's going to make the number sold go down by 2 every time we increase. So we started off by selling 1,000 iPods per day. So that's why I have 1,000. And then we're selling 2 less each time we go down. Next is going to be our price. We started off with $100. And if we increase by $1, so increase by 1x, so each time we increase, that value will go up by 1. Then that's going to give us how much this profit's going to be. So that 100 came from there and the 1 came from there, just so we're all on the same page. So what we actually have here is a quadratic, and we can FOIL this all the way out. If I FOIL this out, I'm going to get, I think, 10,000 plus 800x minus 2x squared. And we're trying to maximize. And this is a negative x squared, which means it's going to be a negative parabola upside down, which means it will have a maximum. So I'm just going to do the x equals negative b over 2a. So I'll get negative 800 over 2 times negative 2, and that's going to give me 200. And you can use your calculator for this one, but no graphing for this, okay? We would have to show our work with the negative b over 2a. Once we have that, they're asking us specifically, what is the price? Okay, so our price was 100 plus 1x. Okay, so we're going to do 100 plus 1 times 200, and that's going to give us $300. So according to this little model, if they sell these things for $300, they're going to maximize their price, or their profit, sorry. All right, here's your turn. Slightly similar, kind of different at the same time. You should pause it and you should try it yourself. Since you probably didn't do that, our revenue slash the profit, right? The same idea for what we're talking about. They're totally not the same idea in real life, but that's okay. Is going to be the price times the number sold again. All right, so a camera store sells 70 cameras per month. At a price of $320 per camera. The manager finds that every time that they decrease the price by 20, they sell 5 more cameras. All right, so we're going to do $320 minus 20x. X is again going to be the either the decrease in price. Yeah, it's just going to be the number of times we decrease in price. Sorry, I kind of had a brain fart there. Next, we're going to do 70. And then it's going to be plus 5x because we sell 5 more iPhone cameras each time we go. Okay, so we have our price is the first one, number sold is the second one. We're going to do the same thing. We're going to FOIL it all the way out. We're going to get some big numbers. You can use your calculator to help you figure out what those big numbers are. But remember, we're not graphing these ones. So we're going to do negative b over 2a to find what the maximum of this thing would be. So that's going to be a negative 200 over a negative 200. So we're going to get 1. So we can only do 1 decrease. They asked us specifically about the price. So our price was 320 minus 20x. Our x value was 1. So we're going to do 320 minus 20. So if we sell these cameras for $300, that is going to end up giving us the maximum amount of revenue slash profit that we can get here. All right, your homework is the practice section. So, there's some optional extra practice there if you want it. 4 big questions that are all based off of what we did here. So we have the modeling projectile motion, we have an open top box where we know the volume. We have an open top box where we don't know the volume, so that's the harder one. And then we have one of these price scenarios here. So hopefully you're able to follow this along, and I'll go over any questions that you might have next class. All right, bye.